There's a car driving around California right now that shouldn't exist. No steering wheel, no pedals. No way for a human to take control if something goes wrong. And according to new permits filed last week, Tesla plans to start building them in about 6 weeks. The Cybercab isn't a concept anymore. It's been spotted on public roads in multiple states. A showroom in Santana Row just put one on display, and people notice something immediately. For specific changes from the original prototype, small details that don't make sense until you realize what they're actually building. This isn't about making a cooler taxi. It's about making a vehicle that physically cannot have a human driver. And the closer you look at the engineering decisions, the more irreversible this whole thing becomes. Let's start with the one detail that keeps coming up in forums, the one engineers can't stop talking about. The battery pack, specifically how thin it is now. Most people didn't pay attention to this at first. Battery thickness seems like a boring spec. But new drone footage from the Texas factory shows something strange. The Cybercab's ground clearance is about 10 centimeters. That's roughly 4 inches. For context, a Model 3 sits nearly twice as high, and the floor inside the Cybercab, it's almost flat to the ground. Here's why that matters. A standard Tesla battery pack is around 10 to 12 centimeters thick by itself. That's just the cells, the casing, the cooling system. If you put that pack in a vehicle with only 10 centimeters of ground clearance, there's no room left for, well, anything. No suspension travel, no structural floor, definitely no space for passengers' feet. So either the drone footage is wrong, or Tesla created a battery that's fundamentally different from anything they've made before. Industry analysts think they know what happened. There's speculation about new cells called NCO5s that are half the thickness of Tesla's current 4,680 cells, around 20 to 25 millimeters per cell instead of 46. If that's true, the entire pack could be under 10 centimeters thick, which would explain the floor height. It would also explain why the Cybercab's estimated range is around 300 miles from a battery that's likely under 50 kilowatt hours. That's an efficiency rate of about 5.5 miles per kilowatt hour. For reference, a Model 3 gets closer to 4. This vehicle is 40% more efficient, using a battery that's 30% thinner and probably 20% cheaper per unit. But here's what people are missing. This isn't just about saving weight or cutting costs. A thinner battery with lower capacity has one very specific advantage in a robotaxi. It charges faster, and it can charge more often. Because if this thing is going to drive 22 hours a day, stopping to charge isn't a problem. It's part of the operating model. Some analysts think Tesla might even deploy 2 versions, a standard range pack for short urban loops during peak hours, and a longer range version for overnight shifts or airport runs. That way, not every vehicle in the fleet is carrying around battery capacity it doesn't need. It's efficient, it's cheaper to build, and it only makes sense if you assume the car is never sitting in a driveway. Now let's talk about price, because this is where things start to feel uncomfortably real. Tesla has hinted that production costs could land somewhere between $20,000 and $25,000 per unit. A lot of people assumed that was marketing talk. But when you actually break down the build, that number starts to look plausible. Start with the Model 3. That car has been in production for years. Tesla knows exactly how much every component costs. Now start removing things. The Cybercab uses a smaller battery, a single motor instead of dual. No traditional paint, which is one of the most expensive steps in car manufacturing. Significantly less glass, maybe 3 panels instead of 8 or 9. A simpler body structure. A simplified braking system designed for city driving, not high-performance cornering. The wheels and tires, because those need to last. A robotaxi putting on 100,000 miles. A year can't be swapping tires every few months. Critics argue that the commercial version will cost more than the prototype. They point to things like sensor cleaning systems, the new AI5 chip, regulatory components like reflectors and cameras. But most of those additions are not expensive at scale. A sensor cleaning system is basically a fluid reservoir and some spray nozzles. The AI chip will likely launch as AI4, not AI5. And even if it upgrades later, producing millions of units brings the per chip cost way down. Early production will be more expensive, obviously. But within a year, a price close to $25,000 seems realistic, maybe even lower as production ramps. And this is where the story starts to get uncomfortable. Because if Tesla can actually build these at that cost, and if they can actually produce them at the scale they're claiming, the economics of car ownership start to break. Why buy a $35,000 car that sits parked 95% of the time when you can summon a $25,000 robot that's always available and costs a fraction per mile? But that only matters if they can actually build them, and that's where the permits come in. Over the past few weeks, Tesla has filed at least 4 new permits with the U.S. government related to Cybercab production. At the Texas factory, these aren't testing permits. They're production support permits. Logistics expansion. Fire safety systems around the new parking structure. Upgrades to the crash testing facility, which is now operational and, according to photos, already has multiple destroyed Cybercabs inside. Permit to 0260007-636. Covers production, support facilities, and site plan adjustments. Aerial footage shows the entire eastern section of Giga Texas being cleared. Old concrete is being crushed for reuse. Trailers and equipment are being relocated. This is what large-scale ground prep looks like. Permit 2,026,014,460 addresses the Western Logistics Area. Tesla is clearing out old contractor parking, expanding internal roads, upgrading drainage, and considering relocating temporary storage structures from the east side to the west. Why? To create a larger staging area. Because they're expecting volume. Another filing covers fire protection and plumbing systems. Around the eastern multi-level structure, Cybercabs have been seen driving along internal routes for testing. As vehicle numbers increase, safety infrastructure has to scale with it. Then there's the ATD lab, the crash testing facility. Federal safety standards are mandatory for selling vehicles in the U.S. This facility is nearly complete. And again, there are photos of wrecked Cybercabs, which means Tesla isn't just testing software. They're testing structural integrity, impact absorption, real-world crash scenarios. When you look at all of this together, it's not a pilot program. It's the groundwork for mass production, and here's the part that makes this feel suddenly very close. Tesla's VP of Vehicle Engineering, Lars Merve, recently pointed out that more than 90% of car trips today carry 2 passengers or fewer. He said this reality directly influenced the Cybercab's design. Translation: Tesla isn't trying to build one vehicle that does everything. They're building a fleet. Cybercab for most trips. Model Y Robotaxi for 3 or 4 passengers. Robovan for groups of 10 or more. It's a system, and the system is designed to replace the way we currently think about transportation. Musk said on the Q4 earnings call that fully autonomous vehicles could serve anywhere from 1/4 to 1/2 of the U.S. population by the end of 2026. That's not a 10-year vision. That's 9 months from now. Expansion plans for the first half of this year include Dallas, Houston, Phoenix, Miami, Orlando, Tampa, and Las Vegas. Some of those markets are still waiting on regulatory approval, but the infrastructure is being built anyway. Early production targets suggest around 1,000 vehicles per month to start. Those first units will likely serve employee transportation programs in Austin. Tesla has done this before. Deploy internally, work out the bugs, then scale to the public. But this time, the manufacturing approach is different. It's not a traditional automotive assembly line. It's closer to how consumer electronics are made. Tesla calls it the unboxed process. Instead of building the car in one long sequence, major sections like the chassis, body structure, and battery pack are assembled in parallel. Then they converge for final integration. This cuts production time dramatically, and it's the only way Tesla could feasibly hit their eventual goal of completing one vehicle. Roughly every 10 seconds. 10 seconds. Not 10 minutes. 10 seconds. That's not car manufacturing. That's something else entirely. And there's one more thing. Drone footage from early 2026 shows Cybercabs driving autonomously inside the factory grounds. No safety driver. No escort vehicle. Just the car, navigating on its own, moving from the production line to staging areas. That's not a publicity stunt. That's confidence in the system. But here's what nobody's talking about. The current Tesla Robotaxi fleet, the Model Es operating in Austin and other cities, still have steering wheels. They still have human safety drivers as backup. The Cybercab doesn't. It can't. There's no steering column, no pedals, no physical way for a human to take over, which means if something goes wrong, there is no fallback. The car has to handle it, every time, in every situation, because there's no one there to grab the wheel. This is the part where people start to split. Some see it as the ultimate confidence move. Tesla is so sure the software works that they're willing to remove the safety net entirely. Others see it as irreversible. Once you put a vehicle on the road with no manual controls, you can't walk it back.